Learner Academy welcomes you all. This is Suja Lex, Assistant Professor from St. Xavier's Catholic College of Engineering, Nagarkoil. This is a third lecture in the series of statistics for data science. This session we are going to learn various numerical measures in descriptive statistics. Now let's move on to the session. What is descriptive statistics? It is a category of statistics which involves various methods that describes the characteristics of a dataset. That is, descriptive statistics describe, summarize, and organize the data. So, it can be easily understood. It measures shape of a distribution, location, and outliers. Various numerical measures are measures of position, also called as central tendency or location measure. The second category is measures of spread or variability, otherwise called dispersion. The third category is measures of shape. Now we can see one by one. In statistics, a central tendency is a central value for a probability distribution. There are three popular central tendency measures. They are mean, median, and mode. Now we can see one by one. What is mean? The mean of a sample is the sum of the measurements divided by the number of measurements in the set. It's also called arithmetic average. Now we can see the properties of mean. Mean can be calculated for any set of numerical data. For a set of numerical data, we have only one mean. It's the most reliable measure of central tendency. It's affected by sometimes outliers. It's used only if the data are interval or ratio type. Now, what's median? Median is the middle value of the sample when the data are ranked in order. The first example, 19 is the middle value or median. But in second example, there are 8 elements, so the median is calculated by adding middle 2 elements then divided by 2. Hence, 19 plus 20 divided by 2, we get 19.5 is the median. We can see few properties of a median now. The median is a value that divides the set of observations into two halves so that one half of observations are less than or equal to it and the other half are greater than or equal to it. It's not affected by outliers. It exists in both the quantitative and qualitative dataset. Next we can see about mode. The mode is the element or value that occurs most frequently in a set of values. Now we can see about the properties of mode. It finds this value which occurs most often. It's a quick approximation of average. It's the most unreliable measure among the three measures of central tendency. For example, median, mean, and mode are equal in normal distribution. It's useful to eliminate outliers. Okay, now we can see about the measures of dispersion. In statistics, dispersion is the extent to which a distribution is stretched or squeezed. Common examples of measures of dispersion are variance, standard deviation, and interquartile range. And finally, we have one more called range. Range is the difference between the maximum and minimum observations in the data set. In this example, 20 is the largest value and 5 is the smallest value. Hence, the range is 20 minus 5, we get 15. Standard deviation measures how much the data values differ from the mean. Now we can see about one more parameter called interquartile range. Half distance between 75th percentile, that is third quartile Q3, and 25th percentile, that is first quartile Q1, is the quartile deviation or interquartile range. So it will be calculated by this formula Q3 minus Q1 divided by 2. Now we can see about the measures of dispersion based on shape. Data can be plotted as a histogram, and every histogram has its own shape or distribution. There are two types of distribution: symmetrical distribution and non-symmetrical distribution. A symmetric distribution is one where the left and right hand sides of the distribution are equally balanced around the mean. Some example distributions are uniform and normal distributions. Now we are going to see the second category of distribution called non-symmetrical distribution. If a distribution is skewed right, we can call it as positively skewed distribution. And if a distribution is skewed left, then we can call it as a negatively skewed distribution. Now we are going to see about measures of shape. Skewness and kurtosis are two commonly used measures. Skewness describes whether the data is distributed symmetrically around the mean or left skewed or right skewed. But kurtosis measures the degree of flatness or peakness of the shape. When the data values are clustered around the middle, then the kurtosis value is peak or greater. When the data values are spread around more evenly, then the kurtosis value is flat or smaller. With this, I conclude my session. If you like this video, please subscribe and share. Thanks for watching.